Welcome to a lesson on the number system. My name is Nketani Handover. I will not want to waste time. We'll straight go into the lesson. Now, what is the number system, or what are number systems? So we need to know that these are numbers that we use to represent data. The commonly used number system here we are talking about is the base 10, which is the decimal number, and it has 10 digits, that is from 0 to 9. Actually, when we are just being introduced to learning to counting the numbering system, we are using the decimal number system, which is base 10. Now there are other number systems, and each of them has a base which determines the number of digits for its number system. We will consider the following number systems. The first one is the same decimal number, which is base 10, which has 10 digits from 0 up to 9. Then the binary number system, which has 2 digits, and these digits are 0 and 1. Then the third one we'll look at is the octal number system. The octal number system, known as base 8, it has 8 digits, which is 0 up to 7. Then we have finally the hexadecimal number system, which is base 16, and this number system has 16 digits or elements. So remember that hexadecimal goes from 0 up to 9, but after the 9 there, base 16, the hexadecimal number introduces certain characters, elements, that is A up to F, to add them to the 10 digits that work in the decimal ordinary to make 16. We have A up to F. So A representing 10, B representing 11, C representing 12, D representing 13, E representing 14, and F representing 15. So let's move on. Now, how do we write these number systems? How do we write this number system? To write the number system, we follow this example here. Let me just get a pointer that is visible, where we have the number. We have the number here, then the base is indicated at the bottom. As you remember, when you are working with Word, we call this as a subscript. So using the subscript, we have the base written in form of a subscript, which will be the base. So examples we have here is 23, which is written in base 10, then 5, 6 written in base 8, and 3, 4, 5 written in base 16. Then we have 1101 written as base 2. So the numbers which are subscripts here are the bases. Note that by default we do not indicate the decimal number base. We don't indicate the base for the decimal number, that is base 10. We don't usually write it. So when you see where we have not indicated the 10 at the bottom, it means that we are dealing with base 10, or the decimal number. Now each digit in a number has a place value and position. Each digit in a number has a place value and a position. The position of a digit refers to the location of the digit within the number and is determined as follows. We check in the next slide. So we move to the next. Now, starting from the decimal point, that is when we are dealing with base 10, then or binary, octal, or hexadecimal point in the number moving to the left, we're talking about your left hand side, to your left, each digit position is numbered from position 0 and increases by 1. And starting from the decimal point or binary, octal, or decimal point in a number, moving right, each digit position is numbered from position 1 and reduces its position by 1. Now the place value of a digit in a number depends on its position in the number. For example, in the decimal number 346, the digit 3 is in the 100 position, and therefore its place value is 300. Its place value, there was a spelling error there, typographic error. Likewise, 4 in the 10th is in the 10th position with the place value of 40, and 6 is in the position of 1s with the place value of 6. Now, as we continue looking at the place value is written as the base, then position as the power. So the base here, then you have the position there. So the base, if you are dealing with the decimal, it will be 10. If you are dealing with the binary, it will be 2, which is the base. Then if you are dealing with octal, it will be 8 base. Then if you are dealing with the hexadecimal, you have 16 here on the base. Then the position is depending on where the location from the decimal point, binary point, octal point, or hexadecimal point, either to the right or to the left, where it belongs to, as is stated earlier. So it is important to note that any number raised to power 0, such as number, then 0 as a power there, use a superscript in Word, or in this case is any number raised to power 0 is equal to 1. That one is very important to note. The decimal point, or binary, or octal, hexadecimal point is indicated as a dot. Let me that we may use to be able to see what we are doing. We are talking about this point here. When you are dealing with binary, it's a binary point. When you are dealing with decimal, it's a decimal point. When you are dealing with the octal, it's the octal point. And you are dealing with hexadecimal, it's the we call it the hexadecimal point. So this is the character that represent that we will use to determine the position we describe from this point. So we have this example here where this table shows where we are saying the table is showing the place value for the digits in the number. We have 562.16. So we have this table here where we have the position, then we have the place value. This place value is written as base, then position. So here we are dealing with the decimal. The decimal which is base 10. This is why we have 10 here being used. We have 10 being used. It's a decimal number. Then the place value is being written as a decimal. Now it's just a compilation of this one, where I have 10 to the power 2, which is 100, 10 to the power 1, which is 10, then 10 to the power 0 is 1. We said any number raised to power 0 is 1. So this is where this one is coming from. Now let me go back to, we need to identify what we mean by the position. Look at the way these numbers are here. We have 562. So from this decimal point, since we are dealing with the decimal numbers, from this decimal point here we have a 2 on the left. So 2 is on position 0. This is why here, if you check, here we have a 0. 2 is in position 0. Then the next one on the left is 6, which is on position 1. 6 is on position 1. You have seen the 1. Then 5 is on position 2. From here we are saying 0, 1, 2. So if you check here, this is how these have been raised. Here we have 2 represent, which is 5 being on position 2. Now to write the place value here, we have said 10 to the power the position. From the way it is here, base, then position. So the base, which is 10, then the position is 2. So computing this one, we have 100. So computing this to the power 1 is still 10. Computing 10 to the power 0 is 1. Looking at the fractional part, let me just pick the pointer. Looking at the fractional part here, earlier on we said that the position starts from 1 going to the right and now reducing by 1. And if you check here, we have -1, -2, because there is a reduction from the decimal point, since we are dealing with the decimal number as a decimal point. So if you check, a 1 here falls under the position is -1. Then the 6, this one, it falls under -2. It will continue to increase as well as you move to the right. So looking at their position there on the place value, you have -1, which is falling under 10 to the power -1, then 10 to the power, the next one, which is 6, is falling under 10 to the power -2. You can compute this to give you a 0.1. This gives you a 0.01. Now this, remember, when you are working, if you are using the normal calculation, you can write 10 to the power -1. To remove the negative, you can indicate it as equal to 1 over 10 to the power 1, which will change to the positive, and computing there to take you to 0.1. This one will be is the same as the 10 as 1 over 10 to the power -2. In short, we have 1 over 100. 1 over 100, changing it to a decimal number, it becomes 0.01. Now multiplying these changes to, it takes you to maybe conversions. This same one is used to convert to decimal numbers. Now we are moving to, is used to for conversion. Now we are moving to the exercise. So you need to work on this exercise and submit, so that we see whether you have understood what we have been talking about. My name is Handover Nketani, teacher of computer studies, computer science, ICT, Mamvule Secondary School, HOD currently for technology and performing and creative arts. See you next time.